We have developed a fast and robust registration method for multiple depth sensors based solely on depth images without the need for color or infrared images. Therefore, we use a checkerboard-like lattice with rectangular holes as target. By identifying this lattice and its hole centers in the depth images, we obtain multiple correspondence points which can be used to estimate the rigid transformation between the sensors. So the main task is to find these correspondence points as accurately as possible in such a depth image. At first we have to identify regions of possible lattice candidates. We do this by looking for gaps along scanlines. These gaps are particularly frequent in the region of the lattice due to the holes. We cluster these gaps based on their proximity to each other. Using various properties of these clusters, we can now filter out many clusters that cannot represent the region of the lattice. For every lattice candidate, we determine all 3D points that could belong to the lattice based on their proximity to the gap segments. To filter out noise, for example due to the flying pixel effect, we use ransack to fit a plane into those points and remove outliers. In these filtered 3D points, we now detect hole centers more or less based on segmentation. Now we need the orientation of the lattice to uniquely assign the hole centers over different cameras. We have developed a heuristic for this purpose. But let's make this example a bit more challenging, since real data is not always this good. Let's assume that we only found these hole centers and also these incorrect hole centers. To determine the axes and filter out noisy hole centers, we first create a proximity graph on these grid nodes only with edges approximately as long as the distance between two neighboring hole centers. These edges are now sorted by the angle they subtend with the x-axis and clustered based on this angle. Now we simply select the two largest clusters and then select the median in those two clusters to represent the directions of the x and the y-axis. Note that at this point, we don't know yet which one is the x and which one is the y-axis and their signs. Additionally, we remove outliers based on cluster membership of neighboring edges. By considering the hands holding the lattice, we align the axis directions such that the x-axis always points to the hands. These detected hole centers and the orientation of the lattice can now be used to create correspondences between the image of different sensors. This way, we are finally able to register the depth sensors into the coordinate system of each other.